Hi guys, this is lesson 2 in unit 11. Today we're going to talk about measures of central tendency and dispersion of univariate data. Let's start with values that describes the center or central tendency of univariate data. When I talk about central tendency, I talk about the center. So the values that you're about to learn are values that describes the center of a set of the data. And the first value is the mean. The mean is the sum of the data divided by the number of data. And the median is the middle value, or the mean of the two middle values when the data is arranged in numerical order. So sometimes you're going to have an odd number of data values, and the median is the middle value once you put these numbers in a numerical order. And sometimes you're going to have an even number of data points, and the median is going to be the mean or the average of the two middle values. Also, the two values that we're going to learn that will describe the spread or the dispersion of the univariate data is first the range, which is the difference between the largest value and the lowest or the smallest value. And you can get the range by subtracting the minimum value from the maximum value. The second value that describes the spread is the standard deviation. And the standard deviation, which we will represent by SD, represented by the letter, the Greek letter sigma. It measures the amount of variation that we have in the data from the average. So the standard deviation describes the amount of variation that we have in the data. A low standard deviation value indicates that the data points tend to be very close to each other and very close to the mean. That means we don't have a lot of variation. And a high standard deviation value indicates that the data points are spread out over a large range of values and that we have many variations. So let's take a look at our first example. A set of 7 men had height in inches as shown below. We have these different values. We have 67, 70.9, 67.6, 69.7, 70.9, 68.7, 69.7, 67, 67, and 71. We're trying to find the mean, the median, which are the values that describes the center, and the range and standard deviation to the nearest hundredth, which are the data or values that describe, which are the values that describe the dispersion or the spread of the data. So before we start doing anything, we need to learn how to construct what we call a frequency table. We have 7 data, but as you can see, we have some of these data repeated. And to organize these data, because statistics is all about organizing data, I need to construct what I called a frequency table. And the frequency table basically is having the value that you have and the the frequency, which is the number of times you see the value in the data set. So I'm going to start by putting the first frequency. So I'm going to start by, and I have the middle column here for whatever I call tallies to organize my data. So the first value I have is 67, and I see 67, 1, 2, 3 times. The second value that I see is, let's go with the numerical order, 67.6, 67.6. And I see this value just once. The next value is 68.7, and I see 68.7 just once. The next one is 69.7, 69.7, and I see that value 1, 2 times. Next value I see is 70.9, and I see that value twice. And the last value that I see, I'm going to squeeze right here, which is 71, and I see 71 just one time. So this is how we construct a frequency table. If you want to eliminate the tallies column, that's up to you. You can just include the value and the frequency of the value. But this is a nice way to construct a frequency table when you have a large number of values. Now we're going to find the mean, the median, the range, and the standard deviation using the TI 84 plus, because the calculator is going to give us these values once we enter the frequency table in it very quickly without doing all the mathematical calculations behind getting all these values. Let's take a look at how we can find these values in the calculator. The first thing that we have to do is we have to hit the stats button, because that's where we need to enter our values, and then we have to hit 1 or enter to edit the values, which is basically adding the values that you have in the frequency table. L1 is going to be the values that we have here, and these values are 67, 67.6, and 68.7, and then 69.7, and and then 70.9, and then 71. So these are basically the values that we have in the data set. And now we need to put in the frequency of each one of these values in the second column, or L2. So the first value was repeated 3 times. Next one was repeated once. The next value was or appeared once. And then after that we have 2 times, 2 times, and then once. And this is how we basically put the frequency table in the calculator. Now we need to calculate the values of the central tendency and the spread by hitting the stats button again. This time we need to use the right arrow to go to calculate. The calculator has a lot of options. We need the first option, which is the univariate stats. That's the univariate data. So we're going to hit enter. Now the calculator is asking you where your list is, which is L1. If you have the list in a different column like L2 or L3, all you need to do is to hit the blue button and choose the lists that you have here at the top of the numbers. The frequency list is at L2. That's where I need to put or to push second 2 for L2 to appear. If you don't add if you don't mention the frequency column, the calculator is going to give you the wrong values because it's going to assume that you have these values appeared once in the data set. Now my list is in L1, my frequency list is in L2. All I need to do is to hit enter, and the calculator is going to give me the values that I'm looking for. Now the X with the bar at the top, that's the mean. So this is the mean, which is 68.95. That's the mean value. The median is where you have to scroll down, and the median appears here, which is the value of 69.2. So that's the median. Now the range, you're not going to see a direct value of the range, but what you can see if you go down is the maximum value, which is 71, and the minimum value, which is 67. And by subtracting 67 from 71, you have a range value of 4. So the range is 4. And now for the standard deviation, if you look here, you have the sigma x. That's the standard deviation value. And I'm asking you to round to the nearest hundredth. That means that your standard deviation for this data set is going to be 1.62. And basically the calculator did all the work for you, and all you need to do is to put down these values. One more value that we need to know is called the outlier. The outlier is a score that is way out of range in regard to other scores. That means we're looking for an odd value that doesn't belong with most of the values in a data set. So here we have an example of a data set that has values between 65 and 97, and if you look at these values, you'll find out that they're very close to each other. You cannot call any of these values as odd or way out of the range of these values. And when we calculated the median and the mean of this data set, we have a median of 84 and a mean of 83.4. And these two values are close to each other. They're not exactly the same, but they're close to each other. They measure the center of the data set. That's why we consider the mean as the best representation of the center, and we accept that value when we don't have an outlier. Now let's take a look at the right, where we add an outlier to the data set, and this outlier that we added here is 0. 0 is out of the range of the rest of the data. It's the odd value in this data. There is a big difference between this value and the other values. I would consider this value as odd. So let's see what happens when we add a value like 0 to a set as an outlier. Now, we calculated the mean and the median for this set, and we found out that the median is 84 and the mean is 79. Now, if you want to measure or if you want to give a good representation of the center, we find out that these two values are different than each other. There is a big difference between them. The mean is 79 and the median is 84, and the mean and the median are supposed to be close to each other. So what we discover here is that an outlier affects the value of the mean. It changes it. It depends on that value. If the value is very small, looking at the other values, that means the mean is going to be less than the median. If the odd value or the outlier is very large compared to other values, that means the mean is going to have a larger value than the median. In any case, the mean in this situation is not going to be a good representation of the center. But the median is. Even with an outlier, the value of the median in this data set did not change. So when we have an outlier in a data set, the best representer of the center is the median, while the mean is the best representation of the center when we have a data without an outlier.